Hey y'all, welcome to Basic Chemistry Explained with Alexa Lolo. And today I'm going to be talking about energy levels and sublevels and orbitals. Yay, getting excited for that, right? Anyways, and here we go. Here's our favorite periodic table, every element perfectly located. Behold, this masterpiece I have split in 4 blocks, the S, D, P, and F blocks.
Why did you do this? This makes no sense. Why would someone do that?
Patience, please. I'll show you the magic this can perform in just a second. Suppose you want to find out how many valence electrons phosphorus has, and how many electrons total, and which of those electrons are in which energy level, and what kind of shapes their orbitals have that they take around the nucleus. Let's assume for a second that you're actually interested in this information. We know that for every consecutive element in the periodic table, the electrons increase by 1. So we can count all the boxes right now, including the box for phosphorus, to find out the total number of electrons phosphorus has. And if we take a close look, we can see that the first 2 electrons are in the first row in the yellow region, the S block. So that means that they're in the first energy level, they're in the first row. They are in the S block, so it's a S sublevel, and there are 2 electrons there. So now we're in the second row and we start with 2s2. Then we get over to the P block and it's 2p6, 6 electrons there. Then it's third row, 3s2 and 3p3. So the electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. What? Easy? Yeah, now try for yourself. These 3 right now, pause the video and try them for yourself, and then I'll tell you the answers and you'll check. 3, 2, 1, ta-da! Here are the answers. Now let's take a close look. As we know, valence electrons are electrons in the highest energy level. So the first big number matters. In the first one, we can see that the highest energy level is 3, so all the electrons in the third energy level will be valence electrons. Now in the second configuration, we see the highest energy level is 2, so every electron in the second energy level will be a valence electron. Now if we look closely at the third one, we can see it's third energy level again. Alright, here's another way to visualize the energy levels and sublevels. The sublevels are the letters, the S, P, D, F, and there's also a hypothetical G. Here we can see the rows are the energy levels, and the columns are the sublevels. And these arrows will show you in what order to fill these sublevels in. First you go to 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Let me really quickly show you the shapes of these orbitals. First of all, I'll tell you that this right now, what you see, is enough for you to know if you're in regular or honors chem in high school. Otherwise, if you are more further ahead, I'll show you pictures that are more accurate representations of what these orbitals look like. Now, the S sublevel has a spherical shape. The P sublevel is more of a peanut shape. And I want you to note that there are different orientations in which these orbitals can be arranged. But this is a more advanced thing, and I will not go over this in much detail in this video. Remember this step-like structure I showed you for representing the energy and sublevels? Well, now let's have some fun and count all the electrons that can fit in each energy level and in each sublevel. So we know that the S sublevel has 1 orbital, the P sublevel has 3 orbitals, the D sublevel has 5 orbitals, and the F sublevel has 7 orbitals, and the hypothetical G sublevel has 9 orbitals. Using some really complicated multivariable calculus, I have determined that the S sublevel can hold 2 electrons, the P sublevel can hold 6 electrons, the D sublevel can hold 10 electrons, the F sublevel can hold 14, and the G sublevel can hold 18 electrons. It's time to count how many electrons there are in each energy level. Well, it's really easy actually. For example, for the third energy level, you would take all the electrons that the 3s sublevel can hold, add to that all the electrons that the 3p sublevel can hold and the 3d sublevel can hold, and you end up with 18 electrons. So, in the first energy level, there are 2 electrons, maximum, and the second one can hold 8, the third one can hold 18, the fourth one 32, and the fifth energy level can hold 50. Alright, that's all chemistry I got to you for today. Oh, don't get sad. I'll make more episodes.